Hi, welcome to another lesson at EDU Solutions Institute. Now, today we're looking at our CSEC Chemistry syllabus. Now, we're continuing from last week's lesson where we actually focus on mole. We looked at some of the formulas that we use to calculate the mole, such as mass, mole equals mass over molar mass, mole equals volume over the volume at STP or RTP, as well as we looked at the mole equals to the number of particles over Avogadro's number. So the starting of today's lesson, we're going to look at three simple questions that will utilize some of these formulas, and then we look into using mole in terms of chemical equations. So stay tuned as we explore a little bit more about the mole concept. Now, let's go. So, question 1 says, what's the mole of 5 grams of CH3OH? Now, based on what we are given, we're given the mass of the substance and we give the chemical formula. So, hence, we can know that to find the mole, we now will use the one that has mass in it. So, it's mass over molar mass. So, therefore, we need to know what's the molar mass of this compound. So therefore, it would be given it to you that C is 12, H is 1, and O is 16. So therefore, the molar mass would be, it has 1 C, so that's 12, plus it has 3 here and 1 here, that's 4 H's, so 4 times 1, plus it has just 1 O, which is 16. So therefore, this is 4 plus 16, 20 plus 12, that's 32 grams per mole. So therefore, we will divide the mass of this 5 by 32 to give us the mole of this substance. So therefore, when we put that in our calculator, we would get 0.16 mole. So this is the amount of mole of this compound, 5 grams. All right. Now let's look at question 2. How much would 0.50 moles of carbon dioxide weigh at RTP? So the important part here is RTP, and RTP value is that 1 mole gives us 24 dm3 or 24,000 cm3. All right. Now we're given mole and we need to know how much does it weigh. So therefore, that means we need to find the mass, which mass is equal to the mole times the molar mass. Right? Now, we have the mole. Do we have the molar mass? No, we don't have the molar mass. So we can calculate the molar mass, which is equal to, for C is 12, and then oxygen is 16, but it's 2 times 16. Therefore, that is 32 plus 12, so that's 44 grams per mole. So therefore, it's 0.5 times 44, which is equal to 22 grams. So we have 22 grams of carbon dioxide that is in 0.5 moles of that gas. Right? Then question 3. What would be the mass of 2 cm3 of bromine gas? Right? Then the RAM, the relative mass of bromine, is 80. Now again, if we want to find the mass is equal to the number of moles times the molar mass. We don't have the mole like here, right? But what we have is the volume. And therefore we know that number of mole is equal to volume over RTP value, right? Because this would be in RTP. So therefore, we can substitute the mole here. So therefore, the mass would be equal to the volume times relative, well, like molar mass over the volume at RTP. Right? So we're substituting this where the mole is. So we find our molar mass, which would be, it's 2 of bromine, so it's 80 times 2, which is 160 gram per mole. All right, so let's go. So the volume would be the 2, the molar mass is 160, and the RTP value, because this is in cm cube, then we have to use a cm cube value of RTP, 24,000. So therefore, this would be 160 times 2, 320, divided by 24,000, which we get 0.013 grams. So therefore, we have 0.013 grams of 2 cm cube of bromine gas at RTP. So notice that we've used the formula and it makes life easy, right? But now what we're going to do is to transfer this simple use of formulas to the real situations of chemical equations. So what happens in chemical equations? Let's take this equation that magnesium plus hydrochloric acid gives us magnesium chloride plus hydrogen gas. Now, this is a step that we will take in the future to answer any question that relates to chemical equations in terms of moles. Now, the first thing is to ensure that our equation is balanced. So, we notice we have 1 mg over here, 1 over here, so that's balanced. We have 1 H here, but we have 2 H here. So therefore, we will put a 2 here. So now we have 2 H's, 2 H's. We have 2 Cl's here, and we also have 2 Cl's here. So therefore, now the equation becomes balanced. Now, so after the equation is balanced, we now check what we have and what we need to find. So let's say we had the amount of magnesium. So let's say we have the mass of magnesium, 0.5 grams of magnesium, or 5 grams of magnesium. Right? Then therefore, what we need to find, let's say we need to find magnesium chloride. So therefore, we now go to the ratio. And the ratio is the numbers that's in front of each compound. So in this case, the ratio would be a 1, and this is a 2, and then this is a 1, and then this is a 1. Because it's 1 magnesium to 2 hydrochloric acid to 1 magnesium chloride to 1 hydrogen gas. So now that we know the mass of each, right, if we are supposed to find the actual amount of moles in that we use, because what this means is that if we use 1 mole of magnesium to 2 moles of hydrochloric acid, we will get 1 mole of magnesium chloride and 1 mole of hydrogen gas. But let's see how much moles we actually use in this experiment. So the mole will be the mass over the molar mass of magnesium, which is 24. So therefore, it would be 5 divided by 24, which is 0.21 mole. So instead of 1 mole of magnesium used in this experiment, it was actually 0.21 moles. And what that means is, because it's a 1 to 2, so if it's 0.21 moles of magnesium that was used, then that means for the mole of hydrochloric acid used in this experiment, it would be 2 times this, which would be 0.42. And that would give us the same mole as magnesium, 0.21 mole of magnesium chloride, and also 0.21 mole of hydrogen gas. So now we know just by how much magnesium we used initially, how much moles of the other substances that were made in this formula. Alright? So therefore, now we know the mole of each thing, we can find anything from it. Because if we want to know what's the mass of magnesium chloride that's produced, we have the mole, which is equal to mass over molar mass. And the molar mass, which would be 24 plus 35.5 times 2. And then we would be able to find the amount of mass. So therefore, for any chemical equation, right, it's easy to find what your unknown is. So let's replicate this for another formula. Let's say we had sodium chloride combining with hydrochloric acid. Sulfuric acid, sorry. So our formula would be Na2SO4 plus hydrogen chloride. So to balance this, we'll go 2 here and 2 here. Alright, so in this case, our ratio now would be a 2 to 1, so it would give us a 1 to 2 ratio. So therefore, in reality, if we're supposed to do this experiment with the same quantities as this formula, it would mean that we need 2 moles of sodium chloride, 1 mole of sulfuric acid, and that will produce 1 mole of sodium sulfate and 2 moles of hydrogen chloride. But in experiment-wise, most times this is not our ratio of what the moles would be. So therefore, if we had calculated our mole of the sodium chloride to be 0.1 mole, then what that means is in our experiment, we use 0.1 mole of sodium chloride, which means that it's going to combine with half of this because it's a 2 to 1 ratio. So it will be 0.05 mole of sulfuric acid, and that will yield 0.05 moles of sodium sulfate and 0.1 mole of hydrogen chloride. So therefore, using the mole ratio of what you know to get what you don't know becomes very important when we're finding mole or any quantity that resembles the mole in any chemical equations. So next week we're going to do some examples, some questions that uses this simple principle, so we'll be able to practice on using the mole ratio to answer any unknown question. So that's it for us this week, guys. Hope you understand more about mole, and I'll see you next week. But please don't forget to like, to share, and to subscribe, so you'll be able to help someone or yourself that will be doing your CSEC chemistry, or you just want to learn more about chemistry. So I'll see you next week. Bye bye.